In this session, I will discuss the impact of meteorological factors on the dispersion of pollutants, and in that we will discuss about the impact of wind, the impact of atmospheric pressure, and the impact of moisture on dispersion of pollutants. So first one is the impact of wind on dispersion of pollutants. Moving air is known as wind, and such movement of air is usually caused by the unequal distribution of atmospheric temperature and pressure over the Earth's surface, and it is also largely influenced by the rotation of Earth. And the direction of wind is always to blow from a high pressure area to a low pressure area, which is a normal pattern, but usually under the influence of the effect. Coriolis effect means it's an apparent force which is happening, or which is acting as a result of Earth's rotation. Okay, and it will have a tendency to deflect. It will cause objects, moving objects, to deflect, as well as the air currents to deflect from its normal pattern. Okay, so the normal wind flow is from a high pressure area to a low pressure area, but due to this Coriolis effect, the normal pattern can be expected to change. Okay, and regional as well as local geological and topographical features also affect the direction and speed of winds. That is, whether it is a hilly area, whether it is a water body, or whether it is a uh, flat terrain, or whether it is a valley. All those factors will affect the direction and speed of wind, as well as the dispersion of pollutants. Next is the impact of wind on dispersion. We were continuing with the impact of wind on dispersion of pollutants, and the quicker heating and cooling of Earth, which is coined by the term known as sea breeze and land breeze. Sea breeze means flow of air from, or flow of wind from sea to land uh, during the daytime, and also the land breeze, that is flow of wind from land to sea during the night time. So such wind patterns also contributes to air pollution problems, and the city of Los Angeles in USA frequently experiences this wind pattern, that is, which carry the air pollutants towards the sea in the evening, and which brings towards the city in the morning. And also the friction layer, that is the layer from 700 to 1000 meter above the earth's surface. In that region the winds are generally gusty, and they are changeable mainly due to mechanical and thermal turbulence. Gusty means it's a term which is having the meaning of sudden outburst or strong, and it is in turn directly proportional to the speed of the wind, this gustiness. Okay, and wind speed can be usually measured by anemometer. uh, if we know the wind speed in a at a particular height, then we can find the wind speed at some other height by using the formula u is equal to u0 into z divided by z0 the whole raised to k. Okay, that term is k, that k is a constant, and it is having a value, it is given a value of 1 by 9 for large lapse rate, 1 by 3 for marked inversions, and say an average value of 1 by 7 is normally taken. And this is the diagram of an anemometer. There are two types of anemometers: rotating cup and propeller anemometers. A rotating cup anemometer is more accurate, and it consists of three cone shaped cups which are mounted symmetrically on a vertical axis. And propeller anemometers are characterized by 2, 3, or 4 bladed propeller which is attached to a vane and mounted on a vertical shaft. Okay, and both the anemometers will give the horizontal as well as the vertical wind direction and speed. And the direction and the speed of the surface wind, it actually govern the distribution of or dispersion of pollutants. That is, higher the wind speed, higher will be the dilution or dispersion of the pollutants, and lesser will be the concentration of the pollutants at the source. Okay, so if the wind speed is low, then the pollutants tend to concentrate near the area of emission. And gustiness is yet another factor of surface wind which determines the extent to which the pollutants are mixed and diluted with ambient air, and it is also directly proportional to wind speed. So if the wind speed is more, then gustiness will be more gusty wind we will say. And likewise it is something, it's a term that is related to the strength of wind or how strong the wind is, like that. Okay. Now the impact of atmospheric pressure on dispersion of pollutants. So a high pressure system which is accompanied by light winds as well as a stable atmosphere, it is found to be a bad condition for dispersion of pollutants, whereas a low pressure atmosphere or a low pressure system associated with highly unstable atmosphere, that is high turbulence prevailing atmosphere, that all will lead to good mixing and rapid dispersion of pollutants. And now the impact of moisture and precipitation on dispersion of pollutants, that is the presence of humidity in air will affect the air quality primarily by blocking and obstructing solar radiation from reaching the ground. Okay, so moisture content in any form that is present in the atmosphere will affect the quality of the air in a particular region. So if it is present in the form of humidity or water vapor, then it will block the solar radiation and thereby affect the air quality. And it also prevents the heated radiations being reflected from the surface. And the humidity also leads to the formation of fog, and it increases the earth's corrosive action. Okay, that is, the fog will trap all the pollutants and thereby it will have a corrosive action on the building, on materials and environment. And also excessive moisture in the form of rain, it is very helpful in improving the quality of the ambient air. It is actually very helpful in improving the quality of ambient air because they wash down all the pollutants which get drained off as runoff, and thereby after a rain the quality of air is found to be better. Whereas in the case of sulfur dioxide like pollutants existing, if it is existing in the atmosphere, then it will combine with the sulfur dioxide will combine with rainwater to form sulfuric acid, and thereby the it will result in the formation of acid rain, and which will have a corrosive impact on buildings and environment, as well as it will cause reduce the pH of the rivers and thereby cause acidification of rivers and all. Okay, so that is the impact of moisture and precipitation on dispersion of pollutants. Now the impact of topography on the dispersion of air pollutants, that is, it is yet another factor which affect the dispersion or dilution of pollutants. And topography, it's the representation of surface features such as mountains, hills, rivers and valleys. So in case of valleys, usually air will have a tendency to flow downhill, uh, just like flowing water. And as cool dense air descends into a valley, it will carry along with it all the pollutants, and thereby the pollutants will get concentrated on that valley. Okay, and as the cool air prevails in the valley, warmer air will be above that. So it will this natural flow of cool air, it will be accompanied by a temperature inversion. Okay, which is found to have a drastic effect on the human health. And also in some valleys, the inversion layer will be several hundred meters thick, which means that the pollutants get trapped in that ground level itself. And in case of lakes and oceans, uh, that is we have already discussed about the sea breeze and land breeze phenomenons. So comparing lakes and oceans, the air that is located over the land heats more rapidly than the lakes and oceans, so which will absorb more heat. And as the heated air rises into the upper atmosphere, it will get cooled and tend to migrate towards the colder air mass which are located above the just over the larger water bodies. And this cycle will begin to continue as warm parcel of air which settles over water, and then it cools, and this cycle continues. Okay, and this cycle, it gets completed uh, during night, as sea breezes recycle the air back towards the cooling landmass. Okay, so that is how the lakes and oceans um, affect the flow of wind, or the affect the flow of air, and thereby in turn it will affect the flow of air pollutants. Then regarding mountains, in some cases they act as natural barriers. Uh, they easily trap the escaping pollutants, and buildings are yet another topographical feature, that is the flow of pollutants around an isolated building. It is characterized by the formation of a cavity behind the building, and there is a zone known as wake zone, and another displaced zone is there. So the pollutants will remain in the wake zone of the building because of the poor mixing between the cavity and the displaced zone. And a normal thumb rule for the stack height is that the height of the stack should be 2 to 2.5 times the height of the surrounding building. Okay, that is, if a factory or an industrial stack is existing in a particular area and a nearby building is there, then the stack height should be 2 to 2.5 times greater than or more than the height of that building. Then only the pollutants can be dispersed effectively. Okay. So here we have discussed the impact of various meteorological factors, as well as the impact of topographical features on the dispersion of pollutants. Hope you understood this. Thank you.